everyone. So far we have talked about an entity, attributes, different types of entities and attributes, and we also had a quick hands-on using ERD Plus to see how we can draw like a sample ERD in using ERD Plus. So just a quick review. We also see different types of attributes like single value, multiple valued, right? Composite and derived attributes. And so the important ones, every entity should have a unique identifier, which is your key attribute. Like for example, for a student, could be student number. For employees, could be employee number. For products, could be product IDs, and so on. So that is a unique identifier, which means later in your table, that like using that key, it can uniquely identify each row. So for example, in your student table, each row represents an instance of a student, right? And it can uniquely identify that, which means no two students can have like the same student number. And then we had multi-valued attribute like phone number or email. If you, for example, in your system, you're allowing users to have multiple emails. Composite attribute like what? Composite attribute. Give me an example of composite attribute. Morning. Name, full name, right? Contains first name, last name, address, including street number, street name, and so on. Derived attribute, it is computed from several other attributes and one other attribute. Like what? Age. We use the example age because, for example, in your database you may store the date of birth, but if you frequently are using age in your queries, then it makes sense to create a new column or new derived attribute age, and so on. So these are different types of attributes. You can see also how to show them using ER modeling. So you show entities with rectangle, attributes with oval, and then these are explaining how to show different types of attribute as well. And we also talked about different types of relationships, right? We have one-to-one, one-to-many, many-to-many relationships. One-to-one, each like instance of one entity correspond to just one instance of another entity. Or one-to-many, when, for example, you have one instance of one entity relevant to many instances of the other entity. For instance, back to the example we covered in class, we mentioned each student. For example, each professor can supervise one or more students, and each student can be supervised by only one prof, right? Or one supervisor. If that is the case, this is an example of one-to-many, or many-to-many? One-to-many, right? And many-to-many is like, for example, students can enroll in one or more courses, and also for each course we can have one or more students enrolled in that course. This is also example of many-to-many. And then we talked about how in relational databases we cannot store many-to-many relationships directly in our tables, right? Because then you had that problem of storing, for example, multiple values in a cell, which we don't want, right? For example, if you have a course table, like course ID, course name, and so on, you cannot like just have a student ID there, right? Because each student can enroll in multiple courses, right? And then you have several courses storing in one cell, which is not possible. So whenever you see many-to-many relationship, what do we do? If you have many-to-many, like for example, a student and course, how you resolve that? Associative entities, right? And so associative or composite entity, we use it whenever we have many-to-many relationship. Like for example, if you have, so this is how you show that. So this is an entity, and this is associative or composite entity. And please do not confuse composite entity with composite attribute. Okay, they are two different things. Composite attribute. What is composite attribute? This is composite attribute, like for example, address, right? Then it means that it contains or it's composed of several other attributes, like a street number, a street name, maybe zip code, and so on. And then, so this is example of composite attribute. And this is composite entity. We also call it associative entity. And this is entity, right? Representing an object, whereas this is an attribute representing characteristic or properties of that object. Now, example, course and a student, right? So each student can enroll in many courses. Each course can have many students enrolled in that course. So this is an example of many-to-many relationship, right? This is a student, and this is course. And then we said they have many-to-many relationship because each student can enroll in many courses. Each course can have many students enrolled in that course. And so if that's the case, you have to convert it either to into two one-to-many relationship using associative entities, right? So this will be converted to associative entity, like enrollment, right? And then you still have this, right? The rest is the same. So if you look at this is an example of a many-to-many relationship, right? So this is many-to-many relationship. And then we talked about how whenever we have this in our design, we have to convert it into two relationships. So these ovals are representing, these are representing a relationship, right? And what is the type of relationship here between a student and enrollment? Everyone, one-to-many, right? Which side is one, which side is many? Is this one? Yes, because each enrollment each enrollment is related to only one student, right? And what about this part? Many, right? Because each student can have one or more enrollments. You can have like several enrollments, one of them for database, one of them for another course, the other for another course, and so on. How about this relationship? So this is a one-to-many relationship, right? And this is also a one-to-many. So when I'm saying whenever we have many-to-many relationship, we are converting that into two one-to-many relationship. This is what I mean. So this is one many-to-many relationship. We use associative entity to break down this relationship into two one-to-many. So for example, each course can have multiple enrollments, but each enrollment representing only one course. So these were just the basic things that we have covered so far. And here you can see the examples. And cardinality is just defining how many instances of one entity can be associated with how many instances of the other entity that we already mentioned. In some models, they also identify the exact numbers, but for like the sake of this course, you don't need that. You only need to specify whether it is one-to-one, one-to-many, many-to-many. We also want to see the cardinality symbols, right? If it is, for example, optional or mandatory, We also call it participation. We want to see whether, for example, a student and enrollment, consider this relationship. So we say each student can have multiple enrollments, right? Now, should a student necessarily have an enrollment, or can we have a student that is not enrolled in any course? Yeah, so depends on your case and your assumptions, right? Let's say you assume that, for example, each student, let's say, for example, at York, we can have students that do not enroll in any courses, for example, in a specific semester, right? And if that's the case, it means that this is optional. So each student can have 0 or more enrollment. So this sign here, this sign, means optional. And if it's mandatory, like if you say, no, we cannot have a student that is not enrolled in any course, and my assumption is that each student should enroll in at least 1 courses. If that's the case, this is mandatory. And this is how you show it. Okay. Now, these can be combined with these different types of relationship, like one-to-one, one-to-many, and form different formats that you see here, right? So, for example, this means exactly 1, and it's mandatory, right? This means it's optional, but it could be more. For example, each student can have 0 or more enrollment. So if you see, the sign is like this, right? And this is what you see here, 0 or more optional. And then we have also 0 or 1 optional. For example, if you say each prof can supervise 1 student, but we can also have some professors that are not supervising any students. So if your assumption is this, that, for example, you can have some professors that are not supervising any student, is this optional or mandatory? Optional, right? So, so this is optional 1, as you see here, right? So 0 or 1 optional. And this is, what is this one? Mandatory, right? This sign is for mandatory, and this is for many. So 1 or more, that means you cannot have 0 instance. For example, each professor can teach 1 or more courses, right? But we cannot have professors that are not teaching any courses. So it is not optional. For example, my assumption is that each prof, so if I say each prof teaches 0 or more courses, right? How do I show this? Each prof teaches 1 or more courses. This sentence is not completed yet. You cannot infer anything yet. When you say each prof teaches 1 or more courses, you also have to mention for each course, you can have how many professors, right? How many prof can teach a course? For example, you may assume that for each course we can only have 1 prof, or we can have multiple instructors teaching the same course, right? That is also the case in large universities like York. You can see that different professors are teaching the same course. So, and each course can be taught by only 1 prof. So if this is my assumption, and you see, like, depending on the case, you may come up with different rules, right? So this is one business rule or one assumption. So here I say each prof teaches 0 or more courses. So in this part, this is optional and many. And each course can be taught by only one prof, right? And I want to see also on this part, this is optional or mandatory, right? So now I have to ask, can we have a course with 0 prof? Can we have a course that is not taught by any instructor? No, that doesn't make sense. So this is mandatory. Now, if I'm adding, for example, professor here, so let's say I'm also having instructors or professors here, right? Now, what is the relationship between course and instructor? If you say each instructor teaches 0 or more course, this is how you show it, right? Each instructor is teaching 0 or more courses. If I say each instructor should teach at least 1 course, is this optional or mandatory? Mandatory. And then what would be the sign? Like this, right? So this means each instructor should teach at least 1 course, can also teach more courses, so 1 or more. But if you say each instructor, we can have instructors, like maybe the prof is research stream, is not teaching in, for example, certain years or semesters, so instructors can teach also 0 or more courses. So depending on your assumptions. Now the other part, and that is why I said this rule is not complete, right? Because I've seen assignments and projects or exam, students just write, each prof teaches 1 or more course. So this is not a complete representation of this relationship, right? You also have to mention, you have to complete your sentence from the other side. So each course can have how many instructors, right? How many instances of course is related to how many instances of instructors. So each course, if I say each course should have at least 1 instructor, this is mandatory, right? And then if my assumption is that each course can be taught by only 1 instructor, just for the sake of like simplicity, then this is 1 to many. If your assumption is that each course can be taught by multiple instructors, then that is many to many, and again, you have to use associative entity. Is this clear? Okay. 1-to-1 relationship, men can marry only one woman. And if that's the case, this is an example of 1-to-1. And so as you see, each instance of the man is linking to just 1 instance of the woman, right? Instructor teaching multiple courses. Each course can be taught by only 1 instructor. This is how you can see it, right? And this is example of many to many. In each course, we have several students enrolled in that course, and each student can also enroll in multiple courses. And we also showed that why we cannot represent this in relational databases. Yes? Yeah, you cannot write like this. So this is not correct, right? So this is the sign. So these are the signs that you have, right? This is optional many. This is mandatory many. Optional 1, mandatory 1. Or 0 or more, 1 or more, 0 or 1, 1 and only 1. And and we also explained why relational databases cannot handle many-to-many relationship, and we have to convert that into 2 one-to-many relationship. Because if you keep your model like this, then later we learn each entity is translated to a table and attributes translated to columns of your tables. And then these links between or relationship between the entities are represented by a common attribute, often foreign keys, which is the primary key of another table. For example, what is the primary key of a student? A student ID, right? So this is the unique identifier or the primary key later in your table for the student table. Now, what is the primary key or unique identifier for the course? Course number, course ID, something like that, right? Now, how do we represent this relationship in our actual tables? Using foreign keys, right? We said using foreign keys. That is the primary key of one table appearing as a foreign key in the other table. So either you have to add a student ID to the course table, right? Which we showed this is not possible, because if you have a course table with course ID, course name, and then a student ID as foreign key, and let's say this is your primary key, and course ID is 32421, 4412, and so on. There are many students enrolled in each course, and in relational databases, we cannot store data like this. They should be atomic, meaning that we should store only one value in each cell. Now, another way, if you add course ID as foreign key to the student table, you will come up with the same problem, because again, each student can enroll in multiple courses and you cannot store that. And that's why we use associative entities. Now, this is explained. I already explained this. Now, another type of entity is a weak entity. So what is a weak entity? Weak entity is an entity that is not strong enough that you want to represent it like as an entity. What does it mean? It doesn't have its own unique identifier. And more importantly, it depends on another entity for its existence. What do we mean? For instance, let's say here at York we have different courses, like for example, databases, data mining, and so on. And these courses have different sections, right? For example, database section M, section N, and so on. So how do you want to represent course sections if you want to design your database? Think of how you want to represent course sections then. So let's say you have a course. So we can even continue with the same model here. So if I want to add course sections to my model, how do you represent that? Think of different ways. How can you add course section? You can either add it as an entity, right? Or as an attribute. This is the most confusion that you may get. Like, you cannot have like, what are the other choices? Nothing, right? So course section is not a relationship. It's either an entity or attribute for the course. So you either want to have like sections here, or you want to have it as a separate entity. Now, most of the time, we design it as a weak entity because course section alone doesn't have any meaning if there is no course, right? So if I tell you section M and you're like, okay, section M what? Course like section M of the database course, of data mining, of AI course, which course? So M, N, A, B, C, these are not like, you cannot identify like a natural primary key for such table, right? When we are talking about a student table, we have a student number as primary key. When we are talking about courses, we have course numbers, right, as unique identifiers of the course. So if I tell you ECS 3421, What is that? Can you uniquely identify the course? Why not? ECS 32421. It is database, right? If I tell you ECS, for example, 4412, is it 10 courses? No, it's only one course, data mining. ECS 1015, Introduction to Database Systems. Sorry, Introduction to Computer Science and Programming. ECS 3421, Introduction to Database Systems. So if I give you the course code, it is a unique identifier. So the course has its primary key and is a strong entity, right? You can represent it as a strong regular entity. Whereas for the course section, that is not the case, because if I'm telling you section M, then it's like, okay, which course? So section M only makes sense if it is like ECS 3421 section M or ECS 4412 section M, right? Or ECS 3401 section M. So different courses can have like these sections, and one like common way to represent course section is showing it as a weak entity. How do you show weak entity? Like this. Double line rectangle. So this is course section. Now, so weak entity is an entity that doesn't have unique attributes of their own. A weak entity is represented by a double line rectangle. Each weak entity must be associated with its owner entity by an identifying relationship. So identifying relationship is this. So we know entities are linked through relationship, right? And while we show like regular relationships like this, like with this diamond, you have to show it with double line diamond. So this is called identifying relationship. We always use identifying relationships whenever we have weak entities, right? So each weak entity has a parent, like for example, in this case, section is a weak entity. Its parent is course, right? Because it doesn't have its own like unique attributes, and it depends on the course for its existence. So if we don't have course, then course sections do not exist. Is that clear? No? Do you have any questions? Okay. So in the example on the next slide, class is a weak entity because section number is only unique if it is used along with another entity like course attribute, course code. Now, for example, this is an example I mentioned, similar to what I mentioned here. If you just say section A, B, C, or section M, N, these sections alone do not represent anything. But if they are combined with their parent entity, then they have meanings. For example, ECS 3421 section M, that has a meaning. So what is their primary key then? Because we said they do not have like their own primary key. So for the section entity, which is a weak entity, is section code a primary key? No, it is not. Yep. Yep, we combine it with the course ID. So together with the primary key of its parent, it forms a primary key. So we have more examples of that later. So existence dependency that I mentioned, the existence of one entity depends on the existence of one or more other entities. For example, section cannot exist if there is no course, right? And a weak entity is an entity that is existence dependent and has a primary key that is partially or totally derived from the parent entity in the relationship. So sometimes you have something like course, and for example, course sections as a weak entity, right? Then the primary key of like that section weak entity will be a combination of course code and section number, right? That is, for example, 3421 section N. That is the primary key. So you can see here, course code and section number together form the primary key. These are just different ER notations using different, for example, format. The format that we use in this class is this notation. So you use, for example, entities, you show entities with rectangle, you show relationships with these diamonds. If it is a weak entity, you show with double line rectangle. If it is, for example, associative entity, you show it like this, right? A diamond inside and inside the rectangle, and so on. And representing like also the relationship and cardinalities like this. So this is the notation that we use in this course. And so here is just the cross-put notation, just in case you see in some textbook or other places online. Now, relationship, we discussed about relationship. It's a link or association between one or more entities. How could it be relationship between one entity? Because we can have unary relationship, which means an entity can be related to itself. Okay, for example, we can have an entity like employee. So in an organization, employees can, for example, have different roles. For example, sometimes an employee can supervise or lead other employees, right? If that's the case, you have an employee as an entity, right, which manages other employees, which are still instances of the same entity. Like some instances in one entity are having relationship within other instances of the same entity. And that is a typical example of a unary relationship. I'm going to explain more about that and how you represent it, but this is just what it means. Association between one entity is like unary relationship, or more entities like what we see here. The degree of a relationship indicates the number of entities involved. The cardinality describes the number of instances of one entity that can be associated with each instance of another entity, and we also explained that. So these are degree of relationships, that is number of entities involved in each relationship. So binary is the most common. So all the examples that we covered so far are all binary relationships. So for example, relationship between employee and department. So each employee can work, for example, in one department. Each department can have one or more employees, right? Or for example, relationship between order and product, right? Each order can include one or more products, and each product can appear in multiple orders, right? Now, unary relationship, as I said, is the relationship between an entity with itself. So it's a recursive relationship, like for example, employee. A ternary relationship exists when three entities are associated. For example, in real estate, sales, buyer, seller, and property. But this is like, you won't have examples of this for your exam. These are the most two important ones for like this course. Now, let's say we have prerequisite for courses, right? For example, I don't know, let's say course ECS 3421 is prerequisite for ECS 4412, right? So some courses can be prerequisite for other courses. How do you represent that? What type of relationship is this? unary, binary, ternary. Yeah, binary. Binary means between two entities. So between what and what? So a relationship between some courses and other courses. So like this. Because this is a binary relationship. So, and then it's like one course can be prerequisite for some other courses, but then we have two same entity. How can we show it? Come on, unary relationship, right? This has a relationship with itself. Some courses, right? Some courses are prerequisite for other courses. And that's what unary relationship is. Or for example, some employees can supervise other employees. So there are like relationship between instances of the same entity, and that's when you use unary relationship. Now, the term relationship type is for when you, for example, to describe one-to-one, one-to-many, many-to-many. Cardinality expressing the specific number of entities associated with one occurrence of the other entity. That is the minimum and maximum. And relational participation, when I'm asking about participation, I mean identifying whether a relationship is optional or mandatory, okay? So these are just examples. Processor. Now, what is the type of relationship here between prof and course in this example? One-to-many. One prof can teach many courses. Each course can be taught by only one prof. So this is one-to-many. Now, cardinality, specifying the minimum, maximum, or the exact number of how many instances of, for example, this entity are related to how many instances of the other entity. So these are the cardinalities. But as I mentioned before, for your exam or assignment, you don't need to specify the exact number, as long as you just identify if it is like one, many, and whether it's optional or mandatory. Like if you identified like this, then that's fine. So for example, now tell me about the participation in this relationship. So each course can appear in many enrollments, right? Now, is this optional or mandatory? Can we have a course appearing in no enrollment, meaning that we can we have a course that no students enrolled in that course? Could be. Not really. It doesn't really make sense to keep a course if no student enrolled in that course. You probably want to delete that course. But if you want to allow that, then this is optional. If not, should be mandatory, right? So assuming each course, like if my assumption is that should appear like in enrollments and should have at least one student enrolled in that course, then this is mandatory. And from the other side, enrollment and course, is this optional or mandatory? Like if we have an enrollment, right? If you have an enrollment, can it like including null courses or no courses? No. If we have an enrollment, it means there was a student enrolling in a course. So from both sides, this is mandatory, right? So if there is an enrollment, it means there was a student enrolling in a course. So from both sides are mandatory. So as long as for assignments, exam, project, as long as you just show these types and participation, that's okay. And here is just more example. Again, you can see none or one, none or more, one and only one or more, and how you present that. This is more example of the relationships. So entities can be related to one another in more than one way. For instance, here in this example, what are the type of relationships you are seeing here? For example, how many relationships exist between employee and department? Two, right? Sometimes two entities can have more than one relationship. So, for example, here, course and instructor had only one relationship, right? But sometimes, like the example you see here, employee and department have two relationships. One relationship is, and this is because in this example, it's because employees have different roles, right? Some of them are managers, leaders, etc. So, for example, one relationship between employee and department is that each employee can work in one department. Each department can have one or more employees, right? So this is an example of one-to-many relationship. Another relationship between these two entities is that each employee is also managed, each department is also managed by an employee, right? Which the role of that employee is a manager, right? But still, a manager is also an employee, right? For instance, let's say employees at York. You consider professors, even if you have separate table, let's say for professors. Some professors are maybe, for example, chairs, right? Department chairs, and so on. So have managerial roles. So if that's the case, then you have this type of relationship, right? Because, for example, some profs are, for example, working in a specific department. That is one relationship, employees working in the department. Another relationship is related to those employees that are managing a department. So employee can manage 0 or 1 department, right? And each department can be managed by one and only one employee. Now, regarding the participation here, who can explain why are these like mandatory or optional here for relationship between employee and department? Yeah. Yeah, and so for instance, each employee is working in one department and only one department, right? Why is this mandatory? Yeah, you cannot have an employee working in no department. So this can, like, under any assumption, this cannot be optional. So please be careful with these things, because later in your project you cannot claim that if it doesn't make sense, you tell me, okay, no, my assumption was that employee can work in no department. This doesn't make sense. If you tell me, for example, we can have a student with no enrollment, I can understand. But if you tell me we can have employee that works in no department, that doesn't make sense. And employee can manage 0 or more department. This makes sense, right? So this is optional. Department should be managed by someone. So again, this part is from this side, each department should be managed by one employee. This is mandatory. And this could also be a one-to-many relationship. So we may have departments managed by more than 2 employees, more than 1 employee. Now, what is this type of relationship? Here, unary, right? We can also see unary relationship here because some employees can supervise other employees. Now, one employee, how do you identify type of relationship when it's unary? Like, for example, one employee can supervise how many employees? You can supervise 0 or more employees depending on your role in that, for example, department. So each employee can supervise 0 or more employees, and that's why you see this sign here. And each employee is supervised by one and only one employee. So each employee should have a supervisor and should only have one supervisor. This is the meaning of this example here. Now, what are supertype and subtype? Now, sometimes we have some entities, like for example, employee with different types. So, for example, we can have full-time employees, contract employees, and so on. Why do we need subtype, supertype? Because they're subtypes, so that those different types of that same entity may have different attributes. Like, for example, you may store some attributes if employee is, for example, full-time, that do not exist if it is contract-based, right? Or, for example, you may have some attributes for, let's say, for students, you can have international students, you can have domestic students. Now, for example, domestic students, you may store different information, like personal information, like SIN number, etc. Whereas, for example, for international students, you may store other information. So they may have different attributes, and they share all attributes of their supertype, but also has unique attributes of its own and relationship with other entities distinct from those of other subtypes. I'm going to explain this with an example so you better understand how it works. For example, employee, if you consider employee as a supertype is the bigger entity that has different types, right? For example, employee can be part-time, full-time, so on. Now, this is a supertype. Now, what are some subtypes? For example, hourly employees, salaried employees, contract consultants, and so on. So as you see, they are all sharing the attributes of the supertype. So they all have employee number, they all have employee name, they all have address, they all have the date hired. I didn't repeat them here, but they all have these attributes. And they also have unique attributes of their own, which is not shared with other subtypes. For example, if for example, we have an hourly employee, they may have hourly rate, right? But this attribute doesn't make sense for salaried or contract employees. Or, for example, contract consultants have contract number, billing rate, etc., which are unique, right? It is not shared with other ones. How do we show it? Like this. So you have an employee with these attributes, right? Now, these are the subtype, and this is how you show them. So we have hourly employee, salaried, and consultant. And as you can see, they have different attributes. For example, hourly employees have hourly rates. These ones have different attributes, and these ones have different attributes as well. But all of them, they share, they inherit all the attributes from the employee or from their supertype. And another thing is that we can have, for example, disjoint or overlap. So for instance, employee, if you say employee is full-time, part-time, we call it disjoint. Why? Because an employee cannot be both full-time and part-time. You're either full-time or part-time. So that's why. Here, overlap means you can have an athlete. So we have different type of athletes like runner, jumper, and so on. But you can be both runner and jumper. You can be runner and cyclist. And this is like a more complete example for the registration system. You see here, so the example that we covered. So I just included more details. For example, for a student, I identified as supertype, where we can have, for example, visa students and domestic students with different attributes. And then these parts we already covered here. Each student can, for example, enroll in, and here, class is just what we mentioned for the section, right? So we can have different sections. Another important thing is that when you have a weak entity, you have to identify its primary key underline like this, right? With dashed underline. So section number, this is just showing or signaling the person who is reading your ER model that this together with course code is the primary key. So the primary key of the class or section is course code and section number. Now each course section or each class is taught by an instructor, right? Which is working in a department. So that should, for example, that part should be connected to the instructor. And do you have any question here about different types of entities or attributes? Yeah.
So the subtypes compared to primary.
Yeah. So for example, but partially, right? They still have, they can get it completely, fully, or partially. Like for example, in this case, we still have section number as part of the primary key, but they also inherit course code.
Sorry, you mean for like student.
Oh, I was telling about the weak entities. Sorry. Yeah, for the subtype and supertype, they get it. Like for example, if we have employee ID as the primary key, then the primary key for the subtypes would be the same. What else? No more questions? Yeah. Here?
Yeah.
Okay, they share all attributes of their supertype. This is clear, right? But also has unique attributes of its own and has a relationship with other entities distinct from those of other subtypes. For example, salaried employees, we didn't have the example in the slide, but for example, salaried employees may have, for example, a relationship with some other entities. But for example, hourly employee have not that relationship with other entities, right? So each of them alone, each of these subtypes are representing an entity, right? And they can have their own relationship with other entities. And so these are just some tips for your assignments. I'm going to open assignment 1. How much time do we have? Okay, that's good. I'm going to open assignment 1 today. Your assignment 1 is an online flower shop. So you go to the website and you are kind of doing like a reverse engineering. So it means that you go to the website and think about how they could have, for example, designed their database, right? And then your first assignment is only the conceptual modeling, that is ER model. So you have to come up with the ER model that they use. And I'm going to explain further about that. So these slides that you see here are relevant to that, just providing more information. For example, for building the ER model, you need to understand business rules and assumptions. What is a business rule and assumption? For instance, each student can enroll in multiple courses, right? Each course can have multiple enrollment. This is one business rule. And my assumption is that, for example, we can have students enrolled in no courses. So you have to specify all these details in your assumptions and business rules. And then after that part that you explained everything, then you draw your ER model. So you have to identify entities, relationships, attributes, and that's it. We also cover relational schema later. A business rule is a statement that defines some aspect of the business. These are just definitions of what I just mentioned. And here are some examples. So this is just showing how you can infer these business rules, for example, from the images or functionalities that are available in an application or website. So if you go, for example, for your assignment 1 to the online flower shop, you can check, for example, this is not the same example, but this is how you can do the same thing. So for instance, if you have this form, how can you infer some business rules? So as you can see, you see the orders here, right? For example, order number, date, and so on, right? So an order has order number and date. Customer has name, address, phone number. Then, for example, product has this information. So these are some of your rules. And then you explain more. for example, an order may contain many order lines, right? And because, for example, what is an order? Set of items that you purchase together, right? For example, in one order, you may have several items. And you also have several order lines. Each order line contains one product item with a specified quantity, as you see here. And so thinking of any kind of like e-commerce website or application, what do you think are the common entities there? In any context, flower shop, I don't know, bookstore, anything. Price, is price an entity or attribute? No, we can think about that. So price, is it an entity or attribute? Does price representing a person, thing, object, place for which you want to store some information? So even if you mistakenly store price or define price as an entity, let's say you make a mistake and you say, okay, price is an entity. So what are its attributes? You don't have any attribute for price, right? But if you have product as an entity, you can define some attributes or characteristic of the product, like product number, price of the product, right? And so on. So that is how you can differentiate between entities and an attribute. So what are some of the entities that you may come up with? Yeah? Payments, right? We want to keep track of payments. So payment is one good entity. We may want to also keep track of products, keep track of customers or users, right? So some entities that are common in all of them are customers, orders, products. Now, depending, like even for your group project, doesn't matter if you're assigned to case 1, 2, 3, or 10. They are all e-commerce websites. One of them is Uber Eats. The other one is, for example, Airbnb. So the context is different, but the concept is the same. So for instance, if you're talking about, for example, Airbnb, you still have some products. What is that product? Houses, hotels, etc., right? For example, for Booking.com might be hotel. For example, auto insurance company could be cars. For example, a flower shop could be flowers, or just they may have also other products, but they still, all of them have an entity for product. All of them have some users that they want to keep track of their information. All of them have some orders, and they may have like some additional entities and attributes that might be different from each other. And then here are, you can see some just example. So this is an example. For example, each customer can place many orders, but each order is placed by only one customer, right? So this is a one-to-many relationship. Now, relationship between order and product. What is the relationship type between order and product? This can be very helpful for your assignment 1, actually. It's very similar. Relationship between order and product. One-to-many. Who said one-to-many? Yeah. Can you explain that? One order can have many products. Okay. Each order contains one or more products. Now, is this complete? Is this rule complete? No. Why not? Because here, product and order, right, are your entities. One should be able to infer the model based on the rules that you define. So if your rule is each order contain one or more product, I can draw this. each order contains one or more products. What about this part, right? So you have to complete your rules, and each product, right, can be included, for example, or appear in many orders, one or more orders, right? Each product, for example, let's say you do grocery shopping, right? So your order may include different products like milk, bread, I don't know, chocolate, and so on. Now, each of these products like milk, bread, chocolate, butter, so on, each of them alone can also appear in different orders, right? By different customers, or even same customer. Like you go today, you buy something, and then in another transaction you buy something else, or you buy the same products. So this is a many-to-many relationship. Or even optional here, right? We may have a product appearing in no order. Like, so this is a many-to-many relationship. And what should it do? Associative entity. So this will break the one many-to-many relationship into two one-to-many relationships. And then this could be your order lines. So this is what this example will present, right? Okay, now I'm going to your assignment, just showing your, or before that, just give me a second to, have you checked my announcement on in-class about your group projects? Yes? Okay. Was the class boring today? Yeah. Okay, here. So for your group project, you may have noticed that I extended the deadline for project proposal. So I posted two announcements last night. First is about selecting your project group. Oh, some of you already did. So if you just click on show group members, you can see that, for example, group 1 is already full. And please try to just join the groups that are not filled yet, okay? Instead of like going into groups with no members, try to fill all the groups, but eventually all of them should be filled. And we are, I think, 18 students in this class. I created 24 groups. Groups are up to 5 members, meaning that one group may have less number of people, which is fine. Honestly, 5 people for your group project is a lot. And do you have any questions about your, like, how to choose your group? You know that you can enter in any group that you like, right? Do you have any questions? No? Okay. So I'm showing also your assignment 1.